We are going to be talking about families of functions. So think about a family, right? In a family, there are the parents and the children. That's kind of where we're going to focus here. Each function that we talk about in this class or in this section is going to be some transformation of what we call the parent function. So you have this like function that you start with. We call that the parent function. And then you do a transformation to that. And if you recall in geometry, I taught a lot of you geometry, there were different transformations. The ones we're going to focus on today are the translations. Do you remember what a translation is? It'll be up and down, side to side. It's a slide, right? So you take something and you slide it to a new spot. You don't flip it, you don't turn it, you just slide it to a new spot, okay? So that's what we're going to do today. The parent function is the simplest form of the function, like as basic as you can go, that's your parent function. Then we will do a transformation from that parent function to the new function that we're going to be working with. So what you're seeing here are the three like simplest versions of the three different types of functions we're going to work with. The first one is called a linear function, meaning we will get a straight line from it. Okay, this is a linear function. The parent function would be f of x equals x. Most of the time, you're used to seeing it as f of x equals mx plus b, where there's a slope and there's a y-intercept and all of that. Those will be the transformations we undergo, okay? But this is like the basic as it can get. It starts at 0, 0, and it's a slope of 1, and it just cuts your quadrant in half, okay? That's the parent function. The second parent function that we're going to work with is this function, f of x equals x squared. Now, whenever you see an x squared there, that should make you think parabola or a U-shaped curve. Every time there's an x squared in there, parabola, okay? This one starts at 0, 0 and opens up just like this. Okay, and then the last one, we don't do a lot with this today, but we will do more of this in the future, so I just want to introduce it to you, is an absolute value function, and this is always the V-shaped curve, it's not a curve, the V-shaped graph. So starts at 0, 0, and then basically it takes the linear one and reflects it over the y-axis is essentially what's happening, okay? But like I said, we don't do much with absolute value. We don't do anything with absolute value today. We will do more with absolute value as the days go on. Okay, so those are the three parent functions, right? These are the parents. This, this, this. When we do a transformation, the ones we're going to do today are translations, okay, slides to a new place. The different ways they can shift are vertically, horizontally, or a combination of the two, okay? So going up and down, going left and right, or combine both of them, go up and right, or go down and left, or down and right, okay? So here's what I want to make sure of here. This is the vertical on the left. This is the horizontal on the right. Oops. Okay. The left side, the vertical shifts are, I always say typical. They're what you typically would expect, or maybe you could say as expected. That's up to you, as expected or typical. In other words, if I have a plus after my function and we're going vertically, we assume plus means we're going where? Up, right? Minus, we go down. So it's what you would expect it to be. You shift up for a plus, you shift down for a minus. However, it's when we go horizontal that it gets backwards, okay? So this one, you want to think opposite of what you would expect. Here's how this one works. Notice your parentheses here, f of x, you're adding k or subtracting k outside of that when you go up and down. When we go left to right, it's going to move inside the parentheses, okay? So this is inside the parentheses. These are outside the parentheses. And these ones are, like I said, opposite of what we would expect. So normally, when we see a plus and we know we're going horizontally, we would expect to move to the right, right? That's the positive side of our x-axis. But in reality, we end up moving to the left, okay? So when there's a plus, we're going to move left. And when there's a minus, we're going to move right. And that's where it can get a little tricky, because vertical is how you would expect it to be, but horizontal is the opposite of what we expect it to be. And then people always say, well, why? Like, why does it work that way? What happens is when it's parentheses inside like that, we're looking for a zero. We're looking for an intercept, essentially, is what's going on. And in order to get a zero, if I'm, let's say, adding 5, okay, plus h is a 5, then to make it a 0, my x has to be a negative 5, the opposite of it, to make it a 0, right? Or if my x is a negative 7, then I want to add a positive 7 to get that 0, to make it equal to 0. So that's what's going on inside the parentheses. Outside the parentheses, it doesn't change anything. And this might all sound like gibberish right now, but it'll make sense as we do the actual problems, I think. So let's just take a look at this first one. Okay, so our first examples, we're just going to be working on the vertical translations. That means we're going up and down on these ones, okay? So look at this first question. How are y equals x and y equals x minus 2 related? And I'm going to color code them so you can see which line is which. If you want to do it with me, I picked pink and blue, but you can pick whatever colors you want. Just make sure you're keeping them the same. So y equals x is a parent function. Now, if you don't remember what that parent function looks like, you know how to graph that. How do you graph y equals x? 0, 0, 1, 1, 2, 2, 3, 3. Everywhere that y and x have the same value is y equals x. Or you can think of it as slope-intercept form that has a y-intercept of 0 and a slope of 1, okay? So when in doubt, plug numbers in. But for now, my parent function here, y equals x, is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on and so forth, okay? So this is going to be our graph of that y equals x, okay? This is your parent function. Now look at this blue equation. According to our chart up here, if we have a minus 2, where are we shifting? Up or down? Down, right? We're going to shift down 2. Now, rather than have to graph that how you know, like, oh, here's my y-intercept, here's my slope, you don't have to do that stuff because it's the same graph, just shifted down 2. So we're going to go down 2 and do the exact same graph. Up 1 over 1, up 1 over 1, up 1 over 1. This is my translation. It slid to right there. Okay, so the question is, how are they related? We would say it shifted down 2, right? That's what this is telling us. That minus 2 is saying go down 2 from the parent function. Does that make sense?
Yes.
Thank you. Okay, look at letter B then. First of all, the parent function, I'm just going to stick with pink and blue here. If this is my parent function, can you tell me what shape it is, that graph? That's a parabola. This is the U-shaped, right? Okay, so the U-shaped curve, the parent function starts at 0, 0, and then if you want to put the first 2 points in, you can. It'll always be up 1 over 1, but then it doesn't follow that up 1 over 1, right? It's a curve. So we're going to go something like this. okay, for our parent function. Tell me, based on this equation, where we should be shifting. Up 3 units, right? So from 0, 0, 1, 2, 3 is going to be here. And then if you want to put those 2 in, you may. You don't have to. You could just do the basic shape of the graph. Excuse me. So you would get your parent function is the pink one. Your blue is the result of a transformation. We slid up 3. Okay. Questions on that? Yeah.
So is parabola just that, or how do we know the measurement of the?
How do you know the measurement of what?
Or like, how do we know how to graph
the parabola? So I always just say, if you go up 1 over 1, up 1 over 1, and then just kind of follow a general curve. I don't care if you make it slightly wider or slightly narrower, but the original function is going to be about that every time. Now, eventually we'll get into problems where, you know, you'll have something like this and it's a really wide parabola or really narrow. We're not talking about that stuff right now. So just make it the standard, like pretty much goes pretty straight up or straight down shortly after you start the point.
So it's okay if it's a little like googling my stuff.
Yeah, I don't need perfection. I want to know that your vertex is in the right spot. That's what we're really messing with the most on this stuff. I'm not picky on the rest of it right now. We'll get there, but not yet. Any other questions on those? Okay, so still in the vertical transformation realm here. What happens if we want to translate our equation up 5 units and it started as this? What are you going to do? You're going to add 5 to that equation. So it's just going to be plus 5 here, but you can simplify that. So what's your new equation going to be?
1 equals x squared plus 4.
Yeah, x squared plus 4 would be a translation of 5 units up from this starting point. Okay, so negative 1 plus 5 is 4, so x squared plus 4. Okay, so letter D then, when you translate down a half of a unit, what's that going to be? Minus a half, right? Minus that 1/2. So this is going to be y equals 3x minus a half. Okay, because we went down. Down means we're subtracting. Up means we're adding. Okay, so letter E looks a little bit different. It's the same thing. Don't let the f of x freak you out. We're taking the function, and if we're going down 3, what are we doing with it?
It's minus 3.
Subtracting 3, yeah. So you get y equals f of x minus 3. Okay, questions on that?
No.
All right. Next thing. So those were the vertical ones, and those are the ones that I feel like are a little bit simpler because you're doing what you expect to do, right? The horizontal ones, these are the ones that are a little tougher because now we're doing opposite of what we normally would expect to do. Okay, so just be careful when you get to the horizontal translations that you do the opposite of what you think you should do, I guess is a way to say it. So for instance, if we are going to translate 7 to the left, okay, so let's say we're at 0, 0. You don't need to write this down yet because I'm going to show you in a minute how you're going to do this, but I just want you to visualize. I'm at 0, 0, and I want to go 7 to the left. 1, 2, 3, 4, 5, 6, 7. Am I adding or subtracting? You would think subtracting, but we're going to do the opposite of what we would expect, right? So we are going to, for 7 to the left, we're going to add 7. But now here's the tricky part. When it's left and right, it's within the parentheses, which means it's within the squared element, okay? So we're going to write this as f of x equals parentheses. So this is going to be squared, okay? But we're going to say x plus 7. So what started as What shape is this, by the way? It's a parabola. Okay, so what started as this parabola is going to shift 7 to the left and become this parabola. Ooh, not my best work. Okay, but the function would look like this. Okay, I'm gonna give you another one we're just gonna still call this A. I'll pick a different color. Let's say same parent function, and I wanna shift 2 to the right. Okay, so I wanna go this way instead. Point goes here, parabola goes here. What is that function gonna look like? F of x equals what? Yes, opposite of what you think. We would expect this is plus because we're going to the right. It's actually the opposite. It's minus 2. And then don't forget to square it, okay? Notice it's inside the parentheses. It's inside that squared piece of information, okay? Okay, questions on any of that? Okay, then put it together. We are going to graph the translation that started like this. What shape is this one?
Parabola.
It's a parabola. Okay, so your parent function right now is here. Starts at 0, 0, goes up 1 over 1, follows that general curve. Tell me what this minus 3 is doing. Moving us where? 3 to the right. Okay, it's inside the parentheses, so that's left and right. Remember, inside is left and right. Outside is up and down. So where is that minus 4 moving us?
That's down.
That is down 4. Okay, so my parent function was the pink. When I shift it, I'm going to the right 3, 1, 2, 3, down 4, 1, 2, 3, 4. So now my vertex is here. And I can go up 1 over 1 from there and draw that basic parabola. Okay, so when it says where did your graph move, what I'm looking for there is we went to the right 3 and down 4. Okay, any questions on that? All right, last thing. Sometimes they're gonna give you a table of values, which represents a function, and ask you to give a new table of values after a certain transformation has happened. So think about this for me. If I am shifting down 4, so let's say we started here, okay? And then I shift down 4, 1, 2, 3, 4. And now my parabola is here. Okay, this one's not necessarily a parabola, but I'm just showing you with a parabola. What value changes from the parent to the new one? Is it the x value or the y value? It's the y value, okay? So what happens when they give you this table of values, your x, if we're going up and down, okay, so if you're changing up and down, x stays the same. Now, if you're moving left and right, it's your y that stays the same, right? It would be your x value that's changing then. So just pay attention to where they're shifting you. If we're shifting down 4, okay, down 4 is only changing our y value. So what is this blank going to be? -1. What's our next one? 0 and 2. Okay, our x values don't change if we're shifting up and down. What is my f of x right here going to be next to my -1? 0. Why? You're subtracting 4. So right here, you're going -4, -4, -4. 4 minus 4 is 0. 3 minus 4 is -1. And 0 minus 4 is -4. Okay, so pay attention to what they tell you. If you're shifting down 4, only the y changes. If you're shifting to the right or to the left, your x value should be the thing to change. Okay? Any questions on that?